Verification of Archimedes' principle. Archimedes' principle states that when a body is immersed partly or completely in a liquid, it experiences an upward buoyant force which is equal to the weight of the liquid displaced. That is, buoyant force acting on an object is equal to the liquid displaced by that object. Let us verify the statement by conducting the experiment. First, fill an overflow jar with water until its spout. Then, place a beaker under its spout. Now, take a solid suspended by a thin thread from the hook of a spring balance. The reading on the balance, that is 750 grams, is the weight of the solid in air. Let this weight be W1. Next, immerse the solid in water, and the water displaced by the solid is collected in the beaker. The reading on the balance when the solid is completely immersed in water is 600 grams. Let this weight be W2. Therefore, it is found that the weight of the solid in water is less than its weight in air. The loss of weight of the solid in water is nothing but the difference between W1 and W2, which is 150 grams. The weight of the beaker with water is 450 grams. Let this weight be W3. Let the weight of the empty beaker be 300 grams, which is named as W4. Thus, the weight of the water displaced by the solid is the difference between W3 and W4, which is equal to 150 grams. Thus, 150 is called the buoyant force. Accordingly, the weight of the solid in air, W1, is equal to 750 grams. Weight of the solid when it is completely immersed in water, W2, is equal to 600 grams. Therefore, the loss of weight of solid W1 minus W2 is equal to 750 minus 600, which is equal to 150 grams. On the other hand, the weight of the beaker with water, W3, is equal to 450 grams. Weight of the empty beaker, W4, is equal to 300 grams. Therefore, the weight of the water displaced by the solid W3 minus W4 is equal to 450 minus 300, which is equal to 150 grams. Therefore, we can conclude that the loss of weight of solids in water is equal to the weight of the water displaced.